In our 7-7 series, up to 7 premium speakers will speak for 7 minutes about the latest news in the technology sector. During this virtual event, experts will present a 7-day market review on the challenges and opportunities faced by the industry. This series is part of Steel Club's events. Check out mmsteelclub.com for more information. It's now been 1 year since COVID-19 has been here, and many countries are continuously working towards faster vaccinations. Israel continues to lead the world in this category, as there are major concerns of new variants from the UK and South Africa. Here in Canada, the federal government is reviewing our travel restrictions to further protect our borders from transferring the virus. There are also major farmer protests in New Delhi, India today, where they're also celebrating Republic Day. With that, we will now introduce our speakers for today, which include Antonello Mordeglia, Connor McMenamin, Thomas Narhoz, and Dr. Falk Florian Heinrich. Our first speaker is Antonello Mordeglia. He is the member of the board at Danieli and president of Danieli Automation Spa. He is joining us from Italy today. Over to you now, Antonello.
Thank you very much. Thank you very much for this invitation and to give me the chance to introduce some of the technologies that is, let's say, new in the world, but is very much oriented to the future of steel industry. I think you can start, if possible, with the first slide, please, that I prepare for this event. Is related to a kind of let's say a review of the method of to produce steel today, and what is our, let's say, our intent as Danieli for the future. As you can see here, you know, even today that we are talking about green steel, most of steel in the world is still produced with the first up, let's say, a technology that is the conventional blast furnace, where practically the energy to melt the mineral is given by coal, coking coal, and with oxygen in the converter. So practically, we have very high environment impact. Let's say that about 65% of the total global production of steel is still handling practically this technology, because it's the most competitive, and is also, let's say, starting from iron ore, is the most consolidated and let's say the most antique. So the point is, you know, but the emission here in this case are very, very high. So in parallel, about the balance, 35–40% of steel is produced by electric arc furnace. There are different technologies. The process of electric arc furnace is about 120 years old. The first electric arc furnace from Mr. Siemens, and then more, let's say, there was some new let's say technologies that came over in the years. Finally, there is another process that is still using the iron ore under the, let's say, kind of elaborated iron, not a natural, as probably for the iron ore at the first slide, the first technology that I mentioned. That is the technology of DRI, direct reduction iron, and plus this output product that is the DRI or HBI, that is a concentrated iron ore, is charged in the electric arc furnace. So what is the point of advantage? The last one that is practically, there are two technologies in the world, is the best in terms of low environmental impact. As far today for this technology, mainly is used natural gas plus electric arc furnace, so energy. This technology from Energiron is practically a join that gives you the possibility. It's very open because you can replace totally the natural gas with the hydrogen. So this practically is something that, in the case you are able to have available hydrogen and electric arc furnace with energy coming from renewable energy, you have practically zero emission. Okay, so please the next slide. So the point is very much to move as much as possible. We need the two components, two elements. One is for sure the hydrogen that must be produced by renewable energy. Other way, we still have an impact on the part of upstream, the energy generation. So this means electrolyzer, but electrolyzer that must be somehow fed by renewable energy. The other side, we need a lot of energy for our electrical furnace that we rename, let's say, give a new name that is we call DDM, Danieli Digital Melter. That is practically a new technology that will give you the possibility with a huge kind of inverters to use the renewable energy to feed the energy to your AC, DC, AC converter. Please, next slide. So in this slide, you can see how we practically apply this technology. We started this technology about 5 years ago as a prototype, and then we did some pilot plant, and then we now step over. We have already a reference in the range of 100-ton digital melters. So we are taking energy from a network. On the left side, we rectify in a DC link that become a DC current, and then back with a powerful transistor. The same we use practically for power storage and for transportation system, high-speed train, normal train, so on, our market components. We produce again AC current. What is that? In between, we have a very big capacitor banks in the way that they are practically keeping the energy in this buffer of energy. And this is a specific point we can inject any energy that we are able to self-produce. The benefit is great because we can, in a hybrid way, practically use the energy from network, weighting the network more and more green, and energy from the self-produce or batteries or fuel cells, whatever we have. But actually, the great benefit in terms of energy input is that there is an open system. Okay, please, next. This is a process that practically compared to the existing technology give you several advantages. There are advantages in terms of productivity because due to the change of frequency during melting, we have the possibility to increase the productivity or decrease the consumption. This is something that we already test and operate in 2 plants, one in Croatia, one in Italy, where practically we are dynamically change the frequency. Usually, if we are like in US, Canada, we have 60 Hertz. If we are in Europe, we have 50 Hertz. But that is a fixed frequency for a normal process. But what we did is a change in the frequency during melting, and we are achieving an unbelievable performance in terms of power on reduction, energy consumption, electrode reduction in consumption. The system is modular, so it's many modules, many inverters, many transformers, small size in parallel to create the energy that you need. So it's also very safe in terms of reliability for the system and for the maintenance. So practically you can see again here in this direct feeding on the left side, if daytime you are able to produce yourself the energy, you can practically use as much as possible energy self-produced for your plant. Next, please. So this is a kind of let's say a kind of plant that we are right now already negotiating with several customers. that is a plant that is designed to be practically totally green. How? Because you can create a kind of DC link inside your plant and run the melt shop, run the rolling mill, and your auxiliaries, all with a kind of self-produced energy or even partially from the network. What is the vision? The vision is that more and more, the world will force us to move, us as a plant makers, to green. We have no many chance to stay away because, who is going to implement this technology will be the winner. Who is going to stay in the existing technology will pay very expensive bill that is called carbon tax. So, and this technology is digital. So digital is outstanding because you can imagine anytime we change this firmware in a device, it looks to be a new device, like your mobile phone or your computer. So I think, in 7 minutes, I cannot say too much, but this is a kind of concept that it became industrial products. And I believe this is a kind of a very good technology for now and for the future to think green, to think a better world. Thank you very much.
Okay, that was an excellent presentation, Antonello. Thank you kindly. Just a reminder that this event is being streamed live on LinkedIn and on our website at mmsteelclub.com. Also, we're now officially streaming live on YouTube. Next, we have Connor McMenamin. He is the president at ChemCoders. He is in Chicago, USA today. The floor is all yours now, Connor. If you can just unmute your microphone.
Okay, am I good to go?
Yes, you are. The floor is all yours.
All right. Thank you very much. Thank you, everyone, for having me. ChemCoders, we are in Gary, Indiana. We are mostly local these days, but it's nice to speak to a wider audience as we are starting to branch out to other geographies. If you could go to the next slide. Many will not have heard of us. We are a small, niche coil coating line in that we are just one location. We've been around since 2001, just outside Chicago, Illinois. We're right next to some of the major steel mills in the United States, in Gary. Our focus is a bit different than many other coil coating lines in that we work with waterborne and a little bit more environmentally friendly coatings. We don't work on the typical garage door pre-paint type project. And I mentioned that we're small and that we are only one location, but by dimensional profile and rated capacity, we are probably one of the largest capacity coil coating lines out there. What makes us a bit different aside from our waterborne focus is our in-house R&D capability, which has been a standout asset in recent years. If you could go to the next slide. We were invited to talk about Intercoat ChemGuard. It's almost hard to describe this product accurately in 7 minutes, but we'll do what we can. At its heart, it is a totally unique waterborne modular coating technology that was developed here almost by accident, but really through trial and error. It is a corrosion inhibitor that we bring to very challenging environments. Customers who use traditional technologies but have a rust issue or a forming and rust issue or a welding issue. We coat this currently exclusively on our line, but are branching out. And the photo to the left that I want to point out is a scanning electron microscope illustrating our coating over galvannealed. If it's not quite large enough, I suppose, but if you look at it, you can see that it's getting into all the pores in the galvannealed coating, which I believe is an A25 or A40, which really helps lock in a very strong, let's call it corrosion inhibition. We call it a zinc life extender over here. Many will not have heard of this product. It's fairly new to market by, let's call it steel standards, but it's about 10 years old. So we would in many ways call it mature. And what has been interesting about it is that it's fairly modular, as I mentioned. So we can pull in certain aspects out of it, plug in other components, and then tailor or change what it's going to do. It's waterborne, RoHS compliant, and we just basically cure it onto a steel strip and drive out water. It's protected by patents in most steel producing regions today. And this is our flagship product over the next 5 or 10 years. Next slide, please. This came about, I mentioned, by tinkering, but through trial and error, and we started producing it in 2010 and 11 after a customer came to us in 2009 from the light gauge construction component area, asking for coating that would allow them to basically upgrade or restore secondary galvannealed, add a coil coating, pass it through a cold reduction process on a strip mill, and then still outlast G40 or Z100, Z90 in a salt spray chamber by a factor of 3 to 4x. I wasn't there at the company at the time, but I would guess that we probably all walked out of the room laughing. And then at some point we got to work and came up with a coating that did just that. Now, I showed this picture a second time, and the reason I show it a second time is to comment that this SEM photo is actually our coating post-coat reduction. So the strip in question here will have been elongated probably through a few passes and 30, 40, 50%. So our customers have really been able to increase linear footage, piece count, and value just by adding a relatively inexpensive coating back onto secondary steel. I spent about 10 years at a major steel mill in Europe and in various different regions, and I did not believe before coming here that such a process was possible, let alone productive, and it has been one of my great surprises to see how strong this product is. Next slide, please. To get into a little bit more detail, I show a photo on the left. This is a G235 or Z700, Z720 perhaps, with a hex chrome passivation on the left, compared against a Z100 or Z90, and then with the Intercoat ChemGuard 315 adding on the right. We prep samples in our lab, both internally and send them out to external salt spray providers. This test was 1,500 hours to 10 to 15% red rust per one of the ASTM norms. And you can see, we haven't shown the whole panel, but you can see Intercoat ChemGuard is a very beefy, very robust corrosion inhibitor compared to some of the thickest zinc coatings that you can get on the market today. Not only did we find in the end that we could really attack corrosion problems for customers, but the fact that we could go through cold reduction allowed us to tackle other problems. So we found that we can create a thin film acrylic for the agriculture industry. We've got self-healing and cut edge protection. So if you're perforating, if you are stamping, we can still help around those edges. We've got an anti-fingerprint product today. We have tailored this to a body in white compatible version, which will be relevant, we expect, for automotive. Two-layer systems for aggressive environments like ammonia and urea. And then also we found that this is quite a good adhesion promoter over certain substrates and in certain systems. So we've taken one kind of crazy idea and multiplied it into 10 or 15 crazy ideas. So it's been really exciting to join the team over the last 2 years. Next slide, please. I will go quickly, just in the interest of time, through applications to show where we're moving. We started in the construction light gauge area. This is an example of a component we've worked on. And then, as I mentioned, we've multiplied this out into quite a few different segments. We are a major bus floor coater in the United States. This has been going for 7 years now. In 2016, we got a little bit more into automotive. That's a rocker arm cover. The actual cover bears the Intercoat ChemGuard. There's an automotive anti-fingerprint part that we started up in 2018, 2019. And then the last part on the right is a tire carrier that goes under a trailer to literally hold the tire. But what's interesting there is we've got into the tinted products. So that is Intercoat ChemGuard with the black tint. And we were actually able to help a customer stop using an e-coat, which they found very expensive. They switched to a hot rolled galvanized, and then we apply our Intercoat ChemGuard with the black tint. They don't have to e-coat anymore. It's not truly a painted system, but it is a very strong corrosion inhibitor, and they don't need a perfect black. So it was a very good new product development for us. Next slide. Thank you. This also makes us wonder at a macro level to what extent we can work on a few larger changes in the industry. For example, if you are able to take a Z100 and provide the corrosion resistance of a Z700, I use Euronorm, but G30 and G235, do you need that many different SKUs? Can you buy G30 with Intercoat ChemGuard and apply them to your entire inventory? Do you need passivations? Because we're doing the job of a passivation and it's a permanent coating. So do you need a ChemTreat? You can save money on zinc if you're a galvanizing line. You can also reduce your CO2 emissions based on applying our chemical instead of buying so much zinc. Now, traditional technologies have a place in the market. We don't claim that we are the end-all be-all, but we think that we are part of a suite of solutions to help the industry address its issues. And then lastly, a common theme I've mentioned over the last several minutes is if we could do this one coating, which shouldn't really be possible, what other options are out there for us? What other things can we try, especially using this modular base that our R&D team has developed? Next slide, please. And then, the question on our end, or others' end is okay, what's next for ChemCoaters? We are a one-line operation currently. We operate chiefly in the United States Midwest, a little bit on the East Coast and Southeast. So for us, it is to almost evangelize our technology. We've got projects in the NAFTA region that we are working on currently with select partners. We'll have orders this year for our product, but galvanized at a traditional galvanizing line. So we will help customers access our product outside of that, let's say 400 or 500 mile range in which we operate. So they can, if they have a corrosion issue in Mexico, they can ask a local galvanizer there to work on it. And then from there, once we are set up in NAFTA, once we have those intricacies of the international development down, we plan to help our customers source even globally. Automotive specs are global in many cases. Transportation specs can be global in many cases for bus and truck trailers. So we hope to expand from our one-line operation in Gary to really be a global solutions provider. So it's a very exciting time. We're all dealing with COVID, but this is the best time to try new things in my view. So thank you for having me. Thank you for letting me present. And
okay,
again,
thank
we
you for your
appreciate the chance to be here.
Okay, thank you, Connor. Very good. That was a well-done presentation. Next up is Thomas Narholz, Managing Partner at NPT AG. He is joining us from Austria today. Over to you now, Thomas.
Thanks, and I want to welcome all the people watching this very interesting seminar. I would like to thank Antonello and also Connor for, let's say, moving everything in the direction we are all facing the issues now, which is green steel, is steel industry decarbonization, and what can be done and which technology can be applied. Next slide, please. We as MPT, we are consisting of a full team of experts coming from the electric steel making, having experience in DRI plants, and having a great process know-how. So we are trained, we are capable to identify and to challenge solutions on the market and to stream these solutions fitting into each single project. Specifically, when we see the market today, we can see that the BOF and BF plants will be burdened in the near future by heavy CO2 costs, which they have to reduce to stay competitive. Please go to the next page. Just some facts why we all talk about decarbonization and what is the challenge for the steel industry. If you see the average global carbon dioxide emissions of the steel industry, we're at about 1.8 to 1.9 ton of carbon dioxide per ton of steel produced. For sure, this is depending on the method of steel production. Just as in the speech of Antonello, when you have an electric steel making plant, depending on the electric energy, how it is produced, for sure you can bring these figures drastically down. And we will have a comparison later on the slides. But what is interesting, the steel industry today globally is, let's say, contributing about 9 to 10% of the global carbon dioxide emissions. For sure, this applies to a huge pressure, political pressure, to do something. And as Antonello also said, we still have 65% of the steel industry produced via the traditional converter route. So here is a big pressure to do some adjustments, which have to be in line with the way steel is produced, the steel grades which are used, because it's not all the BOF plants are not long product producer. Most of them are in the sector of flat products, special projects, specific wire rod, rails, and all this stuff. So it's not easy to simply replace the steel making by electric steel making based on scrap. But what are the results of all these facts? The regulations, specifically here in Europe, are getting more and more stringent. More and more customers, specifically car manufacturers moving into electric cars, demand for steel which is carbon-friendly produced. And also stakeholders, investors, and also the public, they are increasingly looking for sustainability issues. The consequence is the decarbonization of the steel has a top priority to stay competitive for a steel plant and also to maintain the industrial license even to produce. Because in a certain way, the regulations will force us to stay on the business only if we admit some limitations of carbon dioxide. Next page, please. What can be done to push the decarbonization of the steel industry? On the one hand, CO2 formation can be reduced. These are common technologies like to increase the blast furnace efficiency by increased fuel injection like hydrogen, PCI, etc. It can be done by the use of alternative reductants, for instance, to use different fuels like biomass, etc., to reduce the carbon footprint of the reductants, specifically the fuels used. We could capture carbon and use it. There are technologies to capture the fossil fuels and to transform them in new products, and in this way to reduce the carbon footprint. Or we can apply new technology or a combination of existing technologies for decarbonization. This means replacement of blast furnace and converters by electric steel making. With or without preheating, all these technologies have to be evaluated, which fits to each of the sites. Is a combination of DRI plant and electric arc furnace with directly hot DRI charged into the furnace. And here on the DRI plant, we have the option to have it natural gas based as a reductant or hydrogen based, which is a next step in terms of decarbonization of this combination DRI plant and electric arc furnace. And it could be a combination of DRI plant and submerged arc furnaces, like it is also offered on the market. And this can be then combined with or without an EAF, where you can basically produce a pre-melt to be further on processed in the BOF. Next slide. What are the benchmark figures in terms of carbon footprint? If we see the traditional route of blast furnace, blast oxygen furnace, as we said before, it's in average about 1.8 to 1.9 ton of CO2 per ton of product produced. If we go to a natural gas-based DRI-EAF combination, we are around 0.6 to 0.7. If we go to a DRI-EAF combination with H2 as a reductant, we are 0.3. And the carbon footprint of a scrap EAF is between 0.1 and 0.3. And all of this, for sure, is depending on the way the electric energy is produced, whether it's done by solar, water, nuclear, or coal-based power, is depending on the charge mix which we can feed to the EAF. We have a tool for melting which is extremely flexible, which can use scrap, DRI, either hot or cold, HBI or hot metal. If still in existing traditional steel plants we have an overcapacity for a certain while of hot metal, the reductant which is used in the DRI and HBI production, and also the means of transportation, how we transport the raw materials into the plant as an aspect into this calculation of CO2 footprint. What are the actual costs of the CO2? Because this is very important to understand where the pressure is coming from. Actually, the CO2 cost per ton of CO2 as a certificate which is burdened to the steel plant is in the range of 30 euro per ton. And it's estimated to reach a value plus 50 euro in 2030 by the rules at the moment applied by the European Commission. What does it mean? If you compare a furnace with H2-based DRI-EAF production, you have a delta of 1.4 to 1.5 tons of CO2 per ton of steel produced. At the cost of 50 euro per ton, we talk about a burden of 80 to 90 euro per ton of steel just by the way you produce it. And here all the triggers are set in terms of how to produce steel. Next page. What we have seen in a lot of projects where we are involved and trying to implement this in different plants, more and more the route DRI and EAF combination is, let's say, the most favorable solution at the time being. Does not mean that new technologies will come up and change a little bit the equation, but the fact is that this combination is proven and are established technologies, that the EAF is extremely flexible in the charge mix. So means it can be combined in different ways. It can be cold, hot, and always depending on the layout which is possible to implement. The EAF is also fully flexible in tap weight to be adjusted whether you would like to replace the full capacity of an existing plant to increase or decrease your capacities. EAFs, as already said in our first speech we saw today, can be fed by green electric energy via wind, solar power to bring the CO2 factor close to zero. DRI plants can be arranged either very close to the electric arc furnace to have a hot DRI charging for further decrease of the electric energy used in the production, or can be placed wherever the place is, and then cold DRI can be charged to the furnace. It's also the DRI plant capacities are modular adjustable with the liquid steel requirements. And it also, let's say, can cover, which is very important for existing plants, a certain liquid steel quality range, which purely with scrap is not possible to manage. So we always have to look to the final product already produced in a traditional plant. And here we have to find a way to balance the trump elements in the liquid steel. Next slide. Here's just, I think, a very interesting slide where we had a look into the global range of, let's say, ton of CO2 per ton produced. And here we can see that the global range of blast furnace BOF plants is in the range between 1.4 and 2.5, depending on the edge of the plant, of the way the raw materials are used. The global range of electric arc furnaces for section is in the range between 0.3 and 0.7, and the pure electric arc furnace range is between 0.2 and 1. And if we see it in terms of countries in Europe, we can see that the typical mini-mill countries like Italy and Spain are clearly lower in CO2 footprint, which also is then, let's say, a certain advantage in terms of costs for the CO2 certificates. Next slide, please. Next slide. Just a small recap of what we are doing. We are not a typical consulting company. We say we engineer recommendations. Means we are capable to whatever we see in the plant to do from 2D to 3D layout at an early stage. This will allow the plants to really to understand how things can be fit in an existing site. We all have to understand that PF, BOF plants are very often traditionally grown and a mixture of a lot of things arranged. And here for sure we can help a lot to have a clear picture what then to tender to the typical plant suppliers. Next slide. I think we can go over this next slide. We have some references where we're already working on this plant. I would like to come for time reasons to the conclusion. If we summarize the market, we can see that carbon neutrality is a significant challenge for the European, but also for the global steel industry. We think that beside a couple of technologies which are under R&D, the DRI EAF route is currently the most established and advanced technology to replace blast furnace and converter capacities. What you can see, it's a rule of thumb, to replace 1 million ton of crude steel via this route approximately requires an investment of 1 billion euro. This is important for a more global view, because if we see that only in the European community we produce 97 million tons of steel still via the BOF route, it means that to replace these capacities would require approximately 100 billion euro of capex investment. This means to do all this, we need a strong political support in Europe to transform this industry into a green steel production. Because what could be the other effect is that if we are not able to support this on a global range, capacities will be moved out in areas where you have lower environmental regulations, and at the end of the day, it will be a damage to the traditional steel industry and without any effect on the global carbon neutral future. That is in this very short 7 minutes to try to give a little bit an overview of where we are supporting customers right now in several projects. And whoever is interested to join us on this footprint way to make steel greener is welcome to contact us at any time. Thank you very much.
Thank you so much for that great presentation, Thomas. Just a reminder that this event is being streamed live on LinkedIn and on our website at mmsteelclub.com. Also, we're now officially streaming live on YouTube. Our last speaker is Dr. Falk Florian Heinrich. He is the founder and CEO of Smart Steel Technologies. He is joining us from Berlin, Germany today. The floor is now yours, Dr. Falk Florian.
Thank you very much. My name is Falk Florian Heinrich. I am CEO of Smart Steel Technologies based in Berlin. Smart Steel Technologies provides ready-to-use software products for the optimization of the steel manufacturing process chain. And the resulting optimizations lead to permanently improved quality and reduction of energy costs. And this is being achieved without investment overhead for new physical equipment. So mainly what we do is we focus on the existing equipment, on the existing plants and processing lines, and we apply artificial intelligence to these lines in order to optimize energy and quality. And therefore, our connection to the our approach to the topic of sustainability is to reduce waste in every individual stage of steel manufacturing. Next slide, please. I would like to use this very short amount of time to explain this using a very concrete example. And before I go into this in detail, I would like to make clear that everything I am talking about is running in production 24/7 already since a longer period of time at multiple of our clients and steelmakers in Germany. So the example that I would like to explain is how AI can be used to reduce waste in the form of quality costs and quality deviations in flat steel manufacturing. In one of the previous talks today, we already did hear about galvanized and galvannealed products, and one application sector of flat-rolled galvanized steel is certainly the automotive sector. In particular, automotive exposed applications require the highest surface quality, perfect cold forming, and additional strict tolerances for the mechanical properties. When we focus on the topic of surface quality, which is certainly the most troublesome for all steelmakers that are involved in automotive exposed grades, if we focus on that, then we have to admit, or we have to see that in particular the continuous casting process, where the steel solidifies and where the steelmaker produces slabs, is absolutely central for surface quality. In particular, surface defects can originate from continuous casting, but at the same point in time, they cannot, in most cases, they cannot be detected right after casting a slab. And this is where the problem actually starts, and this is also where the problem gets super interesting for applications of AI. Everybody who has been working in flat steel manufacturing knows about this traditional problem of slivers and other surface defects that only appear after downstream processing. This means after hot rolling, after cold rolling, and after galvanizing. This means after those downstream steps, the quality inspection systems installed at these stages, and this means firstly camera systems, automated surface inspection systems, they can detect step by step some of those surface defects which originate from the casting process. But in many cases, this works only sufficiently well after the stage of galvanizing. And therefore, the steelmaker is in a situation where one upstream process, namely continuous casting, is the source of the quality deviations, but only after investing considerable amounts of processing costs in hot rolling, pickling, cold rolling, and galvanizing. Only after all those stages have been passed by the product, only at that time, the actual surface quality can be measured appropriately, because only after galvanizing the respective surface defects are visible and can be detected by surface inspection systems. This is also the case for galvannealed products, which have been mentioned in one of the previous talks as well. So in order to reduce this type of waste, this type of quality costs, one has to one has to make sure that the classification of surface defect types works correctly at all stages, because this is usually not the case. And secondly, one has to map back precisely the quality information obtained in the downstream processes to the exact product position in the casting stage. This second step is something that most of the steelmakers struggle with today, because it involves a tremendous effort to reach the required precision in mapping. Even after this has been accomplished, the next point is how to get rid of the root causes, how to get rid of the cases that lead to the generation of those quality deviations. How to get rid of this? Certainly, everybody involved in steelmaking is aware of the typical mechanisms which lead to the generation of those quality deviations, slivers, surface defects in continuous casting. But the problem is a human being cannot find out which combination of such mechanisms is active at which point in time when a particular slab is being cast. And this is exactly the point where machine learning and artificial intelligence has been applied absolutely successfully by us, because through the use of AI and machine learning, we have been able to actually match the historic production data in detail to the quality results achieved in the past, and to compute automatically settings for the continuous caster in such a way that the defects are not generated in the first place. So the key point over here is not to predict any type of defects, but to configure the caster slab by slab, centimeter by centimeter of cast strand in such a way to avoid the generation of those defects in the first place. And this is, in my opinion, this is a super great step forward, a big achievement from the technological point of view, because it basically applies to everybody who is running a continuous caster on the planet. It doesn't require to rebuild that caster. It works with a caster that is quite new. It works with older casters. The key point is by merging together the data appropriately and by applying appropriate machine learning models, it is indeed possible to reduce the quality deviations and the associated waste and downgrading costs by more than 60% permanently. And this is what we have done with multiple of our customers in the past during the last 2 years. And we plan to expand the same type of approach, namely to compute the optimal operation mode of each machine in steelmaking. We try to expand this to all steps of steelmaking. And in my opinion, regardless of which steelmaking technology will be predominant in the future, one key aspect applies to all those technological choices, namely steelmakers have to reduce waste, have to reduce quality deviations, and have to optimize energy efficiency across those stages. And this is, in my opinion, where modern methods like artificial intelligence and machine learning can play a big role. Thank you very much.
Thank you, Dr. Falk-Florian, for that great presentation. Now, if you have questions, this is the time to get them answered. For those of you who joined using our interactive webinar platform, please use the panel to ask your questions. Before we head into the Q&A session, we have something special for you. Steel Club will be giving away 3.999 fine silver coins to those who share our video highlights on LinkedIn. We'll organize a draw, and 3 lucky winners will receive the silver coins. Our video highlights will be posted daily, so don't forget to share. Just a reminder that this event is being streamed live on LinkedIn and on our website at mmsteelclub.com. Also, we're now officially streaming live on YouTube. We will now enter the Q&A session. My first question is directed to both Dr. Falk-Florian and Connor McMenamin. Sustainability will be an increasing theme for steel manufacturers in the future. What are some of the latest technological advancements and projects that support this cause? We'll start with Dr. Falk Florian. Go ahead, Doctor.
In my opinion, one important technological development are direct reduction units using green hydrogen as reduction agents. This is, in my opinion, a good step into the right direction of sustainable and CO2-free steel production. But already now, energy efficiency is increased by using methods of artificial intelligence. And for instance, the total steel temperature level for liquid steel can be reduced by these methods. And as I explained in my short talk, waste in form of quality deviations can be reduced by methods of AI and is being reduced by methods of AI as well. So in my opinion, there are two things that come together. One is direct reduction plus green hydrogen. And at the same time, also for those plants, the application of AI to reduce waste and to improve energy efficiency will be a very important topic.
Okay, thank you, Doctor. Now, Connor, what is your take? If you can just unmute your microphone.
Sorry about that again. I think it will be a combination of solutions, and I think some of the ideas put forward today by the other presenters are all going to be involved. DRI will be a major item. I recall from my time in Tata, there was the Hisarna project in Europe, which was very exciting for many. There will be a lot of efficiency projects. The United States steel mills, for example, have really, I would say, gotten better. I don't have a quantitative figure, but the secondary steel market in the United States has shrunk drastically in the last decade or two, which is an indicator that there are many fewer quality deviations. And on our side, we look at the zinc consumption because, as I mentioned, we've got some products that can help reduce zinc spend by 1/3 or 2/3, depending on the mix of the given line. So I think it's going to be, there's a number of exciting solutions that are coming out and becoming prominent as we speak.
Okay, thank you, Connor. The next question goes to both Thomas and Dr. Falk. Will hydrogen be the future of green steel, and can it effectively replace coal? Thomas, we start with you. If you want to just unmute your microphone, Thomas.
Okay. Thanks for the question. Yes, for sure, hydrogen, and it was already mentioned also by Dr. Falk, green hydrogen will play a significant role in the future. But I think we have still a decade or 2 decades in front of us where we have to work on an intermediate step for two main reasons. We know that we have very promising projects in SSAB, in voestalpine, to work on hydrogen, steel making and use of hydrogen. But we have two things to figure out, like in other technologies as well, is the production costs of hydrogen to be, let's say, in a certain level. And the second one is the availability of the necessary quantities. If you see before that we have to replace 100 million tons of steel only in Europe, and if you want to do it based on hydrogen as a reductant, means we also need a significant amount of hydrogen available at favorable costs. So we will face an intermediate step. It will be for sure the end of the tunnel will be in this direction. But as already said several times, the combination of utilizing DRI technologies with the melting unit as an electric arc furnace with full flexibility of input material will allow us to have an intermediate step, which at any time can be transferred to H2 as a reductant as soon as the issues of capacity and cost are, let's say, in a certain way under control. Now, Mr. Falk.
Sure, thank you so much. And Dr. Falk, what is your take on this? Dr. Falk, if you want to unmute your microphone.
So in my opinion, hydrogen will replace coke in the long term, but only in the long term. Direct reduction technologies currently use natural gas as a reduction agent, and in the future, this could be replaced by hydrogen. But the bottleneck, like has been said already, is sufficient CO2 neutral hydrogen production at a reasonable cost. And this will take some time until this is available. And it again puts an emphasis on energy efficiency and also on waste reduction in general.
Okay, thank you so much. The next question is for Antonello. Antonello, can you elaborate about MEDA hybrid? How will it change the landscape for the steel industry?
Thank you very much for this question. You know, MEDA is Mini Mill Danieli. It was born as a micro mill, the size grew and became a mini mill. Mini mill could be for MEDA, for long products or flat products. The concept of MEDA is to have, let's say, a number of plants close to an area where is available raw material and the customer. So practically, the fact to have very large plants allocated maybe far away from the user also is something that has to be, you know, now and in the future considered, because the transportation cost will be an issue, is more and more like this. So practically, the idea to have raw material available close to the customer is the potential really future for the steel industry. The point to upgrade, we have upgraded practically the MEDA, the conventional one, to hybrid, is giving us the possibility to reduce more the emission. Okay, so practically, if MEDA is in most of time is based on scrap. Okay, we have seen, we talk about raw material, we talk about hydrogen, but for sure to produce hydrogen is costly. The best is to produce steel as much as possible direct with electricity, green power. Why? Because the conversion from power to hydrogen has a cost. The direct injection in the reheating furnace, for instance, or the melt shop of electric furnace of energy has a lower cost. So all this will be based, this concept will be based on two aspects. One, the production of energy on large scale, renewable energy at low cost. Another point is to link the globe with the global network. Okay, and this is something is slowly happening in the way that whenever we are able to have a global network connected by a global link of energy, like in today, we will have really the possibility to produce hydrogen also at very low cost. MEDA hybrid, as already as I explained before, for the concept of with the QGenius, for instance, so you have the possibility to feed jointly energy, self-produce with any source, with also any battery storage, hydrogen fuel cells, and so on, or network power. So this is something that is a open, let's say, open system that give you the possibility really to operate plants with zero emission. We already did some simulation, and let's say we are very, very close to zero, both for CO2 and NOx. So this is something that, let's say, if we want, even without increasing too much, it's actually almost nothing, the investment cost, the capex. Today, you know, if you really want, you are based on the right location, you have maybe wind, you have sun, we can already make a kind of plant with zero emission based on scrap. If we move to DRI, where we need hydrogen, okay, it will take a little bit more time. We can start a blend of gas, natural gas, and hydrogen. but it will happen not too far away, I think. The next 5, maximum 10 years, we will have a lot. Large investment, very large investment, because the conversion means to convert all the existing primary steel maker based on coke to DRI. It's not too fast, but the technology is available. Thank you.
Okay, thank you. The next question also goes to you, Antonello. Will Danieli digital melters replace traditional EAF electric arc furnace in the near future? And are there more companies opting for the digital melter?
We sold now about eight melters, digital melters. The first prototype happened 5 years ago near Venice. Then then we have some in operation up to 80 tons. We have now 3 more under supply in United States, in Arizona. Out of that, 1 will be based on hybrid technology with solar panels. And then we will have 1 more, let's say 2 more in Asia. 1 is starting up in Japan next July. So, the concept, I think, is very correct. The customer that understand a lot about, you must have knowledge about electronic power, about, let's say, melting process, have seen the benefits to have a digital melter. So for us is a kind of no reverse. You cannot change anymore the technology. You remember when we moved from TAC, from the analog telephone, slowly to digital, and now we are only thinking more and more digital. This is the same for steelmaking. So practically everybody is talking about artificial intelligence, about robotics, about all is in digital, and the only main expensive part in your plant is analog, is the electrical furnace. So we know the benefits in terms of energy saving, in terms of electro saving, and increasing productivity, and also the possibility to use multi-energy sources. So I think the decision for us, the vision we did 5 years ago to invest in this technology was the right one. Thank you.
Okay, thank you kindly. That now concludes our Q&A session. Once again, thank you to all of the speakers today: Antonello Moraglia, Connor McMenamin, Thomas Narholz, and Dr. Florian Heinrich. For MM Steel Club, I'm Neil Kumar, and we'll see you next time on our 7-7 series.